All right, so I'm going to review my tie and nine. So hopefully going through this, we'll kind of understand what's going on. I've written a couple things on the top. These are soluble, insoluble. I did the top three right here and number 6 right here. This is from chip 41. So pretty much just, you need to memorize these four right here. Soluble stuff is sodium, ammonium, nitrates, and then acetates. So these will always stay in water. So it's not going to really partner up with anybody. Things like carbonate and phosphates, they want to partner up with somebody. So if they can, they'd rather not be in water. So that's why they're insoluble. That means they're going to make a precipitate or a solid. If they're not soluble, if they're soluble, they're going to stay aqueous in the thing. So as the first example that we did in class was from chip 40, which is the tufa towers. So in the tufa towers, we watched a video about Mono Lake. And in Mono Lake, you had two different chemicals in it. You had sodium carbonate, which is NaCO3, and it was added to calcium chloride, CaCl2. Okay, both of these, when put in water, become aqueous solutions. So that's what this stands for, AQ, aqueous. Aqueous means that it completely dissolves and dissociates. So remember, these are ionic compounds. They're not covalently bond molecules, they're ionically bond molecules. So that means technically what happens here is sodium's a plus, carbonate is a minus, and because they have opposite charges, they're going to be attracted to each other. Calcium is 2 plus, chloride is minus, so their opposite charges is what's keeping them together as a salt. But when you put them in a solution, it breaks apart. Now, when you put them in together in a solution, we want to see if it's going to make a precipitate. So they're going to switch partners. Sodium's going to see if it wants to pair up with chloride. Calcium's going to pair up with carbonate, and we want to see if it does this, or either dissociate or come together. So it's not going to pair up with carbonate again because sodium's already with it. So we're just going to kind of switch partners. So sodium's going to pair up with chloride, so NaCl. And then I'm going to have calcium and carbonate together, so CaCO3. Now I want to balance my equation. Remember, this is this is plus, minus, 2 plus, minus, so that means we need 2 of these to balance it out, and these little pluses are just there for reference. Then we want to balance the equation itself. Here I put 2 carbonates, so I want to have a 2 in front. I'm going to do a different color so it's a little bit more obvious. 2 in front of the sodium so that my carbonates will be balanced. Then I have 2 sodiums, so I need 2 right here. And then 2 chlorides, which I do right here. So right now it's a balanced equation. You have this thing, and we want to see if these are going to be either solids or aqueous solution. Now right here it's NaCl, so if we look at the very top, these are your solubles. Sodium is always going to be soluble, so it's always going to be aqueous. Here we have calcium carbonate, and a carbonate is insoluble, so most likely will turn solid, and it actually does. So when we mix these two together, we created this cloudy water, and if you guys were careful enough, you were able to make a tufa tower within the beaker. Now this is the molecular equation. Now technically I need to get rid of the pluses, so let me kind of erase it out. So the pluses were used just as reference, but it's not supposed to be there. Pluses and minuses. It's just to make sure that my molecular formula was balanced. So this is our molecular equation because they're together as molecules. Okay. The next one is what actually happens. When you put these things into water, it's aqueous. What does that mean? It's going to be sodium ion and a carbonate ion. So in reality, when you put this in water, it's going to be Na plus CO3. Let me give myself more room. CO3 minus. Same thing here. If you put it in solution, it's going to be Ca2 plus and then Cl minus. So when you put these in solution, they're going to be floating around. Here, technically, you have 2 of these because you have Cl2, and they're going to be floating around in solution. Normally, Na is paired up with them, and they don't want to precipitate. Now, Na has a chance to see if it likes Cl, but it doesn't. But the opposite is true too. These are all floating in solution. Now, calcium can pair up with carbonate, and when it does, it produces a solid. So here we have calcium carbonate. And since it's a solid, we don't write it as ions, we just write it as a solid. Sodium and chloride don't do anything. It's our normal table salt. So it is going to stay as an ion. So these are all within the solution. So we can still label it aqueous because that's technically what it is. It's dissolved in the solution. This one's kind of close. Let me change the color so it's a little bit more clear. Let's do yellow. Plus, plus, plus. And then you're going to get these things, which is sodium aqueous, chloride aqueous. This is a solid. And then let me make sure I balance the equation. 2 here, 2 here, because there's 2, and then 2 here, 2 here. Everything's balanced. All right. So this is our total ionic equation, because it's exactly like our molecular equation, but what's different in this case is that I'm writing the aqueous as the ions itself. Okay, so it's kind of big, it's kind of cumbersome, you have a bunch of ions, but that's actually what's happening. When you put it in solution, these ions are splitting apart. So if this was a solution of this stuff, you have Na floating around, you have carbonates floating around, calcium floating around, chlorides floating around, and then let's see, what am I missing? Calcium chloride, and then another carbonate. So these are all floating around. Well, sodium doesn't really want to pair with anybody, so it's just happy dissolved in water. Calcium doesn't want chloride because that's what the original partner is, so it'd rather be with water, but then all of a sudden it has a chance to hook up with carbonates, and when it does, it forms a solid. So that's exactly what's happening here. So initially they're in the solution floating around as ions. If they have a chance to meet up, they do, and in that case a precipitate happens. That's why sometimes you need to shake it. So they rather pair up together, and that's where you saw it. And like I said, sometimes you have to shake it. Sometimes you have to mix it up to kind of get them together, but they rather be together than within the water. So that's why you get a solid. Now, the middle one is kind of cumbersome, meaning that there's a lot of things going on. So what we want to do with the last version of this is just to focus on one of them, this one. Okay, that's the real thing that I care about. This is my precipitate, so that's the only one I care about. Calcium carbonate. Now, I can't just have one thing on the right side. I need some reactants on the left to give me a product. So the only two that I care about is calcium and carbonate. And I want to make sure I write my ions. So this one is calcium 2+. This one is carbonate minus. And here I have 2, so you need to make 2 here. So this will be your net ionic equation because you're only showing the ions that are going to react to each other or combine to create your precipitate solid. So that's your Me, TIE or tie, and then NIE. Me, tie, NIE. Okay, so hopefully that makes sense. The example here is the 2 for towers. You're going to mix 2 aqueous solutions together. That means these molecules prefer to be dissolved in water. Once they have a chance to meet up, so sodium doesn't want to be with anybody, so it doesn't really care, but calcium could find a new partner. So instead of chloride, it could pair up with carbonate, and when it does, it produces a solid. So that's how a precipitate works. These are the 3 different forms I could write. This is what I'd like you to memorize. And this, if you have this memorized, everything else is insoluble. So that's the best key, and sometimes I'll just give it to you. So it just depends on the situation.